Hi guys, David here with another science update. So today we're going to talk about the Mars 2020 Perseverance rover, and in particular we're going to focus on something that was new to me and maybe is new to you, which is how the Mars 2020 Perseverance rover goes about collecting samples which will eventually be returned to Earth. So one of the main missions of the Perseverance rover is to search for signs of ancient microbial life, which will advance NASA's quest to explore the past habitability of Mars. So kind of answer the question of whether it was ever possible or whether there was actually life on Mars. So there are a couple ways that you can do this. One way, of course, is to collect samples on Mars and analyze them using the onboard equipment of the Mars rovers. But there are some limitations to that, as we'll talk about further in a little while. And so the main thing that needs to be done if we're really going to answer this question, most likely, is to actually drill and collect core samples from Martian rock and soil and then really analyze those samples in depth. Unfortunately, we don't really have the equipment to analyze them in depth to the degree that we would need to, so at some point those samples need to make it back to Earth. And the reason that I'm talking about this today in particular is because lately, even in the last week, we've been getting more updates about the terrain that the Mars Perseverance rover has been exploring. According to the first peer-reviewed scientific paper that's come out from the data collected by the Perseverance rover so far, it's clear that basically they managed to land the Perseverance rover in probably the best possible place to find signs of life, if signs of life are to be found at all. So this paper is from Science, and it's called Perseverance Rover Reveals an Ancient Delta Lake System and Flood Deposits at Jezero Crater, Mars. By analyzing patterns in the rock and other geological features, they were able to essentially conclude that there was at one point a full-size lake in this crater of water, and they said the delta architecture at Kodiak indicates deposition in a closed lake system under fluctuating water levels and changing styles of flow during later stages. This indicates that the climate on Mars at that period was warm and humid enough to support a hydrologic cycle on the Martian surface, at least episodically. And that's pretty much ideal for the formation of life, as we know, is liquid water over a long period of time. But what's interesting, if you look at the phases of the Perseverance mission, according to NASA, you have several stages. There's launch, obviously, where you're lifting off from Earth, and then the voyage through space to Mars, and then the approach, entry, descent, and landing, instrument checks and first drive, and then surface operations, which is learning about Mars through the day-to-day activities of the rover, and that's what's going on now. But what's interesting is there's nothing in here about returning samples to Earth. And so I had to do a little bit of further looking to find it, but apparently the Perseverance rover will actually be making or collecting and packaging samples, which will eventually be brought back to Earth, but it actually is not within the scope of this mission to bring those samples back to Earth. So I found this really cool pictorial illustration of how this is going to work from BBC. And what this does is it just shows a bunch of simple animations of the entire mission process overall. And so the first step is stuff that's already happened. So a new rover built by NASA named Perseverance will land on Mars in February 2021. Obviously that's happened already using the sky crane method. Then Perseverance, a 6-wheeled robotic machine with 23 cameras and a drill, will seek signs of ancient life in a large crater called Jezero. That's what's happening right now. It's collecting rock and soil samples that look like they may have been altered by contact with microorganisms. And I was wondering, is it easy to tell if a rock has been altered by a microorganism, or is it easy to tell if there once were microorganisms in a particular place? And according to my reading, it really might not be that difficult. So it's really essential that we actually get these samples back to Earth, because in some cases we'll need to do a lot of cutting, drilling, microscopy, and other things like that. So according to one article I found linked below, the dead fossilized bodies of microorganisms can be difficult to find in ancient rocks. Scientists can work around this by looking for evidence of life that can survive over time, such as biomolecules. By searching for substances associated with life, scientists can determine whether or not life existed when the ancient rocks formed. So it's possible when they get these samples that they'll just be able to put it under a microscope and say, hey, look, there's fossilized bacteria or something like that. But the chances of that happening and that the the bacteria would be fossilized the right way, which is, first of all, it's kind of difficult for that to happen. It doesn't happen most of the time. And then that they would be preserved in such a state that they would be observable is really low. So what's most likely going to happen is that these analytical techniques are going to be really involved and maybe even require the development of new methods. And so the idea that you could, put everything on the shipboard, that the Perseverance rover itself could do all the analysis, is just not going to happen. And that's why it's really essential that these samples get back to Earth. So the rover will store its samples in metal canisters, but leave them behind on the Martian surface to continue its mission. I guess they don't have to worry about anyone, like picking them up and stealing them, of course. Later this decade, after 2026, a second, smaller rover to be built by the European Space Agency will arrive on Mars. This Fetch rover will travel across the surface, picking up the sample canisters left behind the Perseverance. And then the canisters will be loaded into a protective container and placed into a small rocket, the Mars Ascent Vehicle, or MAV. This will blast into the sky, placing the container into orbiter on Mars. It will then be collected by a satellite that's going around Mars. And then this will act like a cargo ship, bringing the precious rock and soil specimens back to Earth. And this is still in 2026, so it looks like it'll take about 5 years for the satellite to arrive home. And then it will basically release the package, which will have been put in a protective capsule to avoid burnup upon re-entry. And then it will be analyzed on Earth using whatever techniques we can come up with. And this is an interesting detail. You can see that the person working on the sample is working in a glove box. So the samples will have to be kept in an inert environment so as to avoid degrading them. Anyway, I thought this was interesting. I think it kind of answers the question of how we're going to get samples back from Mars. We obviously think a lot about how to collect samples, but in my mind, I generally assume that any analysis is going to be done on Mars itself rather than bringing them home. But I think that the ability to bring them home is probably essential if we're going to actually fulfill the parameters of the mission, which is to discover whether or not life on Mars happened at all. Well, thanks so much for watching. This has been another Science Update. If you enjoyed the video, please go ahead and like and subscribe, and I hope you'll join me again in the future soon.